Hey, this is Justin here with First Updates Now. I'm here checking in at the Peachtree District Championship. I'm with 1414 IHOT. I've got Sanche, Henry, and Nick. They're going to talk to us a little bit about their whole intake, the wrist that they've got on it, and the whole arm that it's all attached to. This is Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University has over 25 pre-college camps and learning experiences available, from computer science and engineering to inspiring future women engineers, leadership development, and first-based camps for first graders to graduating high school seniors. Magna and GM-sponsored camp fee scholarships are available. Email ctaylor@kettering.edu for more information.
I'm going to pass it off to Sanche, and he's going to get us started today.
So the first thing I wanted to talk about is this wrist right here, you might see. So it's actually the last joint of a 3-jointed arm, and it's powered by a pretty unique gear, right? You see that interesting profile? It's a herringbone profile that we custom designed and 3D printed to make sure that we would have no backlash in that last stage, just so that we could move the wrist how we wanted and always know which position it was in. And the 3D printed gear has held up really nicely. We designed it in on shape, and it's powered by one little Neo 550 in there through a 2-stage gearbox because of this custom gear. So what's on the end of that wrist? I'll hand it over to Henry to talk about the intake.
Yeah, so one of the main parts of the robot, and probably the first thing you notice, is the arm. And one of the more unique aspects about having an arm on a robot is we can actually intake and outtake from both sides of the robot. And one way we take advantage of that is through the use of this intake. Compared to models similar to this, we actually have 2 rollers on either side. So pretty much the intake is mirrored regardless of what side it is on. We also have it geared such that when we turn the motor in one direction, it's able to intake cones, but that also serves as the intake for cubes. And then when we outtake the cones, that serves as the intake for cubes, if that makes sense. So I'll hand it off here to Nick, and he can talk about our carbon fiber arms.
Yeah, so another notable aspect of the robot is our unique decision to use carbon fiber as the main body of the arm. We wanted something really light and durable to keep the low ratio from arm to chassis weight, so that when we were moving the arm around, we wouldn't be crazy tippy. And obviously, regardless of the really lightweight material, we needed a pretty strong force to move it. And for that, we have like an all-in-one kind of gearbox, and I think Henry will explain that.
Yeah, so we have our main gearbox here, which controls both the elbow joint and the shoulder joint through these 2 different chains here. And so pretty much this gearbox is mirrored on both sides, and we have different sets of gears depending. We have a lower gear ratio for our shoulder joint and a higher gear ratio for our elbow joint. So another question we get a lot is how we chose these specific carbon fiber tubes, and well, my answer to that is through a lot of testing. Here we have 1/8 inch wall carbon fiber tube, and here we have 16th inch carbon fiber tube. So yeah, like Nick was mentioning, the main benefit to carbon fiber tube is lightweight and high strength, especially with the speeds that we are trying to run the arm at.
Yeah, and programming-wise, one of the most interesting things was being able to control this arm. So we actually use Motion Magic profiled PID controllers on all of our arm motors, and they run surprisingly well, and it allows us to create like smooth compound movements and basically make the arm follow trajectories. So we give the arm inputs for like what position it has to be at a point in time and how fast it should be going, and the arm will travel in like a smooth path through that point. So yeah.
Great, thank you guys so much. It's a very sturdy robot that you guys got here. It's performing great in the competition, and good luck to you guys in the rest of your matches today.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University has over 25 pre-college camps and learning experiences available, from computer science and engineering to inspiring future women engineers, leadership development, and first-based camps for first graders to graduating high school seniors. Magna and GM-sponsored camp fee scholarships are available. Email ctaylor@kettering.edu for more information. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.